Okay, and now I'm out of presenter mode
Nope,
again.
you're back to,
Oh, now you are.
there we go, you're back again.
There we go. And I'm going to change the screen so I stop losing this. All right, so we're here to talk about venting, polypropylene venting. So the first reason is, why do we want to even talk about venting? Why? Because if we don't properly vent these appliances, people can die. Carbon monoxide poisoning is real. Also, there could be a great deal of property damage from the water vapor created from those exhausts. So we're going to go through and talk about that just a little bit. There are still carbon monoxide related deaths happen out there, about 430 a year. And it used to be up in the couple of thousand range. That was back in the days when people didn't know any better. They'd start up their generators in the garage and end up killing themselves, not realizing that creating electrical power was creating carbon monoxide. They've safeguarded against those types of things now. Now most of the deaths are due to leaking carbon monoxide from appliances, and the problem is that when it occurs, it's all considered a great big accident. Nobody really goes to look and see what has caused it. So now, with the different levels of carbon monoxide, you can die at different rates. People have gone down to find out why their water heater wasn't working, and it turned out that the basement was full of carbon monoxide, and they never got out of the basement. Then there are those that are just in the room getting headaches, getting nauseous, getting sick. And I got into polypropylene venting. A very nice family won at an auction out in Colorado. Not won in an auction, but had the highest bid for a ski lodge. And they went skiing for Thanksgiving Day weekend, and a subpar contractor. And I say that because all of the wholesalers and contractors that I spoke to in the Colorado area defined him as that. But he didn't have the PVC venting glued together properly, which doesn't make him subpar, just makes him one of the many who doesn't realize all the things that go into actually getting a good PVC vent system. Not that there is a good PVC vent system. But having said that, the family of four died over Thanksgiving, and the next day their friends came to go skiing with them, only to find that the house was locked up and they were inside having been asphyxiated by carbon monoxide. Having now depressed everybody, I think I've got your attention, right? So we put in these great things called carbon monoxide detectors. And here you can see the alarm response time, 400 ppm, anywhere from 4 to 15 minutes, okay? 400 ppm. So if we look up here, okay, you got an hour to 2 hours. It's only life-threatening after 3 hours, but that's presuming that the 400 stays at 400 that whole time. As it works, it doubles and goes up to 800. Now death within 2 hours. As it doubles again, death within 1 hour. Any way you're looking at it, this thing is causing brain damage, not good for you. Don't want to leak in the house. Carbon monoxide are good safeguards if you're far away from the carbon monoxide source. But if this is down in a kid's basement playroom, you can understand how this could be a very dangerous situation. Hands up? Can you hear?
Jim, why are these sensors triggered at 400? Can't we make them more sensitive and give everybody a lot more time to get safe?
Well, if you made them a lot more sensitive, they'd go off a lot more frequently, and then people would start ignoring them and disengaging them the way they do with smoke detectors.
And I mean, you know,
At their own risk.
Sorry, what you say, Jason?
Educating these customers that they understand the repercussions of CO poisoning and how they have to recoup from that. I mean, you got to depressurize yourself.
Oh yeah,
So
it's at least 24 hours in the hospital, if not weeks in the hospital, to get the carbon monoxide completely out of your system, and that doesn't take away from the effects it's already had on your body.
Yeah, that's a good point to bring up to everybody.
Jim, what people don't understand about carbon monoxide is it attaches to the red blood cells and blocks oxygen from being attacked. And it takes 10 times longer for carbon monoxide to come out of your bloodstream than oxygen. And
Right.
this is where the death thing comes in, right? That's where the purple fingernails come in, the nausea, the headache, all that bullshit, and the death, right? So yeah, it's important.
Well,
Yes,
you
it
know,
is.
Like Malik has a comment here. He says, you know, do you really believe it causes brain damage? You know, Jim, I don't know if you can jump on this, but I think it does because you're depleting your brain from oxygen at certain points, and it's going to affect the brain. I think it will. That's why they make you go through deep compression because they want you to get that out of your system.
Right. Yep. So yeah, carbon monoxide, very, very serious. It is a silent, odorless killer, and so it's not to be trifled with, and therefore I consider it very important, and I consider what I'm providing a safety device. It's something to secure life.
Well, you know, Jim, I got to go back to what you're talking about here in the vent system because I had a guy recently in for our training session in New Bedford, Massachusetts. That's open to everybody. Gentleman, one of Steve's guys from New York, the Five Boroughs, one of the startup guys that do a lot of stuff for our local rep there, who's our manufacturer's representative there. They do a lot of startups commercial wise. And they had told me, I said, listen, I just want to pick your brain. You guys are from the Five Boroughs. I know a couple years ago, more than a couple years ago, you guys had a situation where you had CO poisoning in a dwelling and it killed a lot of people. He says, yeah, it was a restaurant and it killed more than 5 people. So it was something that opened their eyes up in the Five Boroughs. You can't use anything unless it's, polypropylene or something that's certified venting. So
Right. So yeah, the New York City has banned using PVC as a vent, and most of the surrounding area has some type of verbiage that creates that. Massachusetts has now required that PVC be listed. Um, the director of the Department of Buildings Boiler Department in New York City also didn't want CPVC. And so while the city council wouldn't let him ban CPVC as well, what he wrote into the New York City code was plastic pipe used as a vent system must be installed according to its listing. And since there's no CPVC with a venting listing, it then gave his inspectors the authority to reject those installations.
that's pretty smooth. That's pretty smooth. You got to give him that because he kind of
Great,
wigged that
great
out.
guy. Passed away, Bob Daly. I liked him a lot.
Yeah,
All
that
right,
was
I'm going
pretty.
to try and move on so I can try and be done here by 8 o'clock. I
You're
don't
good.
think there's Thursday night football tonight, so we can't stick around because there's nothing to run off to. All right. We also discussed the water damage. So a little bit less critical, but still, for every 100,000 BTUs, you're creating a gallon of water. It doesn't really sound like a lot. You can hold the jug in your hand, no big deal. But when that starts seeping into your bricks, now you can start seeing the discoloration all around the building. They think that it's water seeping in, so they paint it. That only makes matters worse because now the water has no place to go but inside the house. So now you got the plasterboard and the sheetrock falling off the walls because the chimney wasn't relined to accept the newer, higher efficiency boilers that we're coming out with, that essentially the exhaust is steam as it's coming out and it's condensing within feet of the boiler itself. So that brings in Snap Rabbit. What makes this so great? Well, you can use it to reline those chimneys. It's a gasketed system. It's environmentally friendly. It's going to go in less than half the time that it takes you to put in PVC. And, for all of you contractors who feel like piping in because you've used polypropylene, please let all of your friends know, because anytime I give this presentation and there's a polypropylene using contractor in there, he raises his hands and lets everybody know, hey, I've used this stuff. It is going to go in less than half the time. So speed is huge. Speed is going to save you money in labor and time. And it's what helped Steve get off the job in 8 hours, putting a brand new boiler into the system. Polypropylene is a heavy duty plastic. It is not heavy. It's just a superior plastic. So we can use half the wall thickness and still have a higher temperature rating than you're getting with PVC or CPVC. Having half the wall thickness means that it's lightweight. It has over a 30-year history of being used in Europe. Like most products, it takes Canada about 15 years for them to use it in Europe before they start using it. And then it takes the US about 5 to 10 years after Canada starts using it to say, yeah, this is a worthwhile product. We should be doing something. We have a full line for all your high efficiency products, and our acceptance rate and approvals are growing over and over. We're accepted on all of the NTI products. Me and Jason Thompson are tight. All right, environmental facts. Polypropylene is what?
That's a good person to be tight with. One of the smartest engineers in the industry.
Yes, he is.
Yeah. He's a very, one thing I like about Jason, he accepts things. He accepts the growth and change in the industry. He's smart.
Well, and I like the fact that he's very blunt about things.
Oh, blunt as you can be.
Not many people are going up there to visit with them up in what is it, St. James?
St. John's.
St. John's.
Yeah,
well, whatever it is, I went to the one in Newfoundland instead of the one in New Brunswick. Ended up having to take a very early morning flight. I was all red-eyed, and Jason was just like, "What are you doing here?" I was like, "I came here to visit you." He goes, "No other manufacturing salespeople come in to visit me." I was like, "Okay, well, I'll be the first, but I'm here to help when you need me."
It's like The Godfather. You got to make an appointment.
There you go. So, environmental facts. Made out of carbon, hydrogen atoms. You can see the little crystalline structure. If you go look up a polypropylene molecule, the complete combustion of polypropylene is going to create carbon dioxide and water. It has a low manufacturing carbon footprint because it is formed and molded at very low temperatures. No pollutants are released during the manufacturing process. So unlike PVC, where they're discharging chlorides and heavy metals into the environment, stainless steels where they have forming oils that they're releasing into the environment, you have none of that with polypropylene. All right, voice is a little better. We talked about speed. So here's the thing. It is a more expensive material. It is an engineered material system. It is designed to be a vent, so more goes into it. So it costs a little bit more, about 50% more than your PVC. So don't get sticker shock when you see that material, because you got to really think about the fact that this is an entire installation. If I'm saving you half the price, if you've got a 3-inch, 24-foot system, and I go in half the time, we're going to be saving you money on your total installed cost. And if you have to use CPVC for a larger commercial type of job, we're less expensive than CPVC and more readily available than CPVC.
Hey,
Well,
hey, Jim.
That's huge. That's huge.
Jim, quick question. So someone asked, is it mass approved?
Yes, it is.
Thank you.
Jim, does it fall under same standard as IPEX?
So IPEX came in and they spent, so here's the thing. They're still calling it PVC, but I worked with the IPEX people for over a decade because we were up in Canada. When they got the Canadian codes changed, they immediately trademarked the name System 636. And they immediately trademarked the name System 1738. But it took them another 16 years to change around their PVC so that they can meet the UL 1738 standard. And so the question is this really still PVC or is it something else? I haven't gone to the equipment manufacturers and said, hey, you've approved PVC, but you don't know what that System 1738 is. Now, I'm sure it's a good product, but you still have to glue it together, which makes it a far more complex product. right?
Well-
So
Well, the other thing is the glue, plus you have to use a special primer. And guys tell me when I'm on a job, they're like, I don't want to use somebody's. If I go into a wholesaler, I want to buy primer, wherever I can buy primer, I can buy PVC glue. I don't have to buy a special PVC glue or primer. Now with this vent system, they have to buy that. So that's another additional cost that they look at. And that's something the contractor at the end of the day is looking at, like, I have to spend an additional cost. You know what I mean? Like
Sure.
with your vent, they don't have to, go through that whole caboodle to get to where they need to be to fit the standard. That's what I'm saying.
correct, correct. So with ours, we're fire retardant polypropylene. Our locking system is comprised both of the gasket and the locking clamp. As you get into the larger diameters, you can actually meet the safety standard requirement without a locking device. So 6-inch and above, per the safety standard, a locking device is not required. Per best practice and good common sense, use the locking device. You're going to lower this vent down the chimney, and you're going to hope that a gasket is going to support the weight of all the vent, especially after you've put lubricant on it to put it all together. You're trying for mission failure. Put the locking clamp on. It's a security factor, and it's something that that'll make your life easier in the long run. The gasket is an EPDM rubber, so for those of you who are saying, oh, I've had gasketed systems, those gaskets turn to a white powdery substance. That's those silicone gaskets that were on stainless steel vent systems. The acids immediately ate away at those silicone gaskets. And oh, by the way, the issue with the metal vent is those silicone gaskets were all the way at the back of the socket, which means they were being put right where all of the condensates build up. So condensates build up in the gasket pocket, dry up, leave salts behind, get wet again. So now there's more salts in there. That means it's a higher concentration of acid. You're looking at a pH level of like 1.6 or less as this starts building up. That plus as the salts dry out, they look for moisture and they pull the moisture out of those silicone gaskets. And that's how you get that dry rot, powdery, nothing there in the gasket socket.
Destroy
Polypropylene, the gasket is way up at the top with the proper pitch. Condensates will never get to it. And with the EPDM rubber, it's much more aggressive against the condensates that come up against it. We're currently certified to ULCS 636, which pretty much every equipment manufacturer accepts. We are going after the UL 1738 just because I was born in the USA, and I believe if there's a USA safety standard, then we should be going for it. So I've convinced my organization that that's what we're going to do. Our maximum temperature rating is 230 degrees. We are good for oil. Has to be a low flue gas temperature below 230 degrees. There are a couple of those boilers out there, and then natural gas and propane. For the gas systems, we are rated for category 2 and 4 appliances. So category 1, for any of you who don't know, are the atmospheric boilers, right? Natural draft, the heat buoyancy of the flue gases bring it up, but it creates a negative pressure, that buoyancy. So if there's ever a hole in the pipe, it's actually going to suck air in. Category 2 is much the same way, except within that pipe, the flue gas temperature is a little bit lower and you can build up condensates. So you need a material that can withstand that 1.6 pH that I was talking about before, and that's where polypropylene comes in. It can handle that lower temperature. It can handle those condensates. Category 3, think the water tube steam generators, think the older tankless water heaters where they were just pounding hot air through there as quickly as possible with a high-powered fan. So you had a positive pressure in the vent and you had flue gas temperature so hot that you were never going to see condensates in there. They got smarter and they realized that just because it only turns on when we need hot water, we still need to have a condensing tankless water heater. So now we have condensing boilers, condensing tankless water heaters, and with those condensates now in a positive pressure, you need to have control for both. So you need the gasketed system or a sealed system for the positive pressure, and you need a material that can withstand those very low pH levels. Okay, we said it was a superior material. So chemical resistance, much better than PVC or CPVC. Think aromatic hydrocarbons, think solvents, think paint thinners, any type of a solvent where it's got that pungent smell. Think about the fact that PVC is designed to be solvent welded. So all of those solvents eat into PVC, and all of those solvents are on your job site. If you go look up PVC and things that it should not come in contact on the job site, you will find a 4-page list, and 75% of the items on that 4-page list are going to be on your job site in one way, shape, or form. Our working temperature, I put 248 here because that's what it's rated to in Europe. In the US, we have different standards. Not that it's higher, it's just that they do not test at 120 degrees Celsius. They go from 110 degrees Celsius to 150. By making that jump, we can't go to 150, and it would be a special test here in the US. But it's 120 degrees Celsius, 248 degrees. At 248 degrees, you're still in our working temperature. You're already softening PVC and CPVC to the point where it's probably going to melt. We already discussed environmentally friendly, no chloride leaching, so none of the chlorides are going to come back from this vent system into the heat exchanger that you just installed. And we are on the top of the chain for being a fully recyclable product. PVC is not. Okay. We talk about weight. Think about the fact that you spent the entire morning installing this boiler. Maybe you did solder, maybe you did press fit, maybe the hydraulics did most of the weight for you, but you were holding that, 10, 15 pound hydraulic gun all day long. Now you have to start humping vent system down into the basement. Do you want to carry something that's 58 pounds per foot, or do you per 10-foot length, or something that's 14 pounds per 10-foot length? So if you're doing a commercial job with 6-inch venting, you're probably going to be using CPVC. You have to have 2 workers carrying that 58-pound, 10-foot length down into the workspace, where one worker can carry 30 feet down of the polypropylene. Huge, gets rid of the fatigue factor. You almost just want to throw it across the room. It's so light and easy to handle. Yes, sir.
I noticed on your flexible vent kit, you guys have that nice support that goes in the bottom of the chimney base. I really like that. I saw that on your kit. So great job, man. I like
We're
that.
We're going to go there. And it is a nice piece, but I'm going to show you a piece that's even better. Just wait. Okay, so more on my slamming of PVC. Okay, so PVC, you've got this nice mess. You've got your primer on there, and now you shouldn't actually ever be doing this because the primer is supposed to be going on right before the solvent, and the solvent is supposed to be going on right before you put it together. The people that are doing the dry fits and the pre-priming, those are the ones that are going to end up with the bad solvent welds, and we'll show you what happens there. But regardless of all that, 30% chlorine by weight for PVC. That means you've got halogens in there that are going to be toxic. When it burns, it produces dioxins, chlorocarbons, and hydrochloric acid. Think about a firefighter having to go in to fight that fire where he knows he's got chlorine gas and he can't take his mask off, and he's got hydrochloric acid, which is trying to etch his mask away. So it's not a good environment for them. When they saw that when polypropylene burns, it creates carbon dioxide and water vapors. The reason the director for the boiler department had such an easy change was because the fire marshal was at that training to train the licensed plumbers of New York City on the new dual or redundant firefighting equipment that they were, fire extinguishing equipment they needed to put into buildings. So other advantage of polypropylene, it can be assembled and disassembled. It's a gasketed system. You don't need to cut a coupler away and put a new coupler in. No VOCs. So unbeknownst to me, until I started looking up VOCs cause liver damage, kidney damage. So think I can't drink as much anymore. Think nervous system and carcinogens. right? We got to get rid of VOCs. Not good at all. No flammable fumes, and those flammable fumes that are in the solvents can actually trip off water heater explosive fume sensors. So there you are. You've just put in the brand new water heater for your customer, and the solvent has tripped that off. You go to turn it on and show your customer they're going to get hot water, and the explosive fume sensor is tripped, and you're like, okay, let me check this out. You find it, maybe you reset it. Some of them actually have to be replaced because of it. It's just a hassle, right? Why deal with flammable fumes when you can have a gasket system? And no cure time. And I'm not talking about the cure time of we need to wait a day before we start a system. I'm talking about you push the 90 on, you turned it 90 degrees, probably turned it 95 degrees, and now it's a little bit off. You then try and spin it back. Then you're going to hold it together for some amount of time, depending upon how cold or moist it is. And if you're not, then you're really going to end up with a bad solvent well, because those pockets are tapered and they push away on each other. So if you're not holding it together until that solvent has at least cured that much, you're going to have a bad well. I was once on a job and they were putting in a PVC system. Don't know why they started from the top, but they had a PVC pipe hanging out, and there was a guy on the floor with a PVC elbow, and he had a 3-inch wide paintbrush, and he's painting primer on. And there's a guy on the ladder, and he's painting it on with the 3-inch primer brush, and there's a guy holding the ladder. 3 people, right? And then they do the same thing with the solvent. They run over with the elbow, they put it on there, and they give it a twist. I start laughing, and the foreman is like, well, what's so funny? I said, what's so funny is what you are doing to put this system together. I said, you could have had my stuff all done already. He goes, oh, bull. I said, well, how long are they going to hold it? Because now there's one guy holding the ladder, one guy holding the elbow. And at one point, the other guy had to come back so that they can switch. He goes, what difference does it make? I said, because if they're going to be there long enough, I'll run out to my car, I'll get my 6-inch diameter pipe, and I'll build up a little system that can lead all the way to where they are in the ceiling. I did that. He asked me where I was 2 months ago, and I said, trying to make this appointment with you because this stuff is fast and this stuff works great. So here are the problems with a poor venting choice like PVC. The heat makes it deform and distort. So if it's got a gasket in it, that gasket is not going to be sealing that distorted piece of pipe anymore. It's discoloring. Something bad is happening if it's discoloring. Properties are changing. It's no longer the same material that you initially installed. Yes, sir.
Steve has what you call the PVC rainbow.
Yes, I do.
PVC rainbow.
We've got the initial white. We've got the whatever color that is with the primer, and then we've got the beige. But they say it doesn't happen, so we like to show it with the couplings in there that say, yep, heat didn't get to here, but it certainly got to here. And then you can see the exhaust and you can see the air intake.
Jim, you don't understand. It goes white, yellow, tan, brown, pink, purple, black, and gone. And I've seen it in all those stages. So PVC has a lot of color range. Sorry, I'm back.
It's called the rainbow. It's called the PVC rainbow.
Yeah, there you go. A good name for it. And then here's that bad weld. And I think that they tried to put the solvent on there. I don't think it was just a dry fit job, but I think what happened was they didn't hold it. And so it started to ride off, and then the laws of physics apply. And when it expands and contracts, it pulls apart. And then for those of you who've ever put in furnaces, and I don't know if anybody here has, but all the furnace guys are always telling me, oh, it'll never happen on a furnace. Never happen. And please ignore the name. I'm going to keep my laser over it so that to protect the quasi-innocent. It wasn't their furnace's fault. It could be that they didn't change out the filter. It could be that they didn't put it in the filter at all and they just clogged up the entire heat exchanger. Or what most people don't realize is you're putting these in, you put it into a zoned heated house. Those zoned heated houses have a bypass valve to make sure that there's enough air flowing through the furnace that it doesn't overtax the fan, and so that the furnace acts at its efficiency. Well, that bypass valve is just sending hot air back to the furnace. I've had zone valve manufacturers let me know that in their labs, they got flue gas temperatures up to 195 degrees. I'm not going to go back the 7 slides, but if you remember, it was 176 degrees where PVC got soft. So this was soft PVC somewhere above 176 degrees that just collapsed under its own weight. And you can see it's kind of white up here, and it's got the PVC rainbow starting to occur. Okay, then there are the other polypropylene manufacturers, so we need to make sure we dish them as well. So things that we have that they don't have, and you were talking about that nice little base support at the bottom. We have this thing called a chimney bend. So it's a support at the bottom of the chimney, but it's also got a cover plate that covers up the opening of the chimney. And we'll get into that a bit more later on. On top of that, we have it also set up so that you can put a double flex in there, one for combustion air and one for exhaust. Chimneys are not allowed to be used to bring in combustion air in the voided space. And that's a perfectly sound code, because here in North America, you could have burned wood in that chimney, you could have burned coal in that chimney, you could have burned oil in that chimney, could have burned gas in that chimney, all of the above, could have had kerosene, diesel fuel, anything that you could burn could have gone through that chimney. So you've got all of those oils and creosotes and everything else coupled with the mortar and the ceramic tile, none of which is going to be good coming into an air inlet. So you don't want to use the voided space in a chimney to bring in your combustion air, unless you really don't like somebody like I did at my brother's house. Oh, no, just kidding. So with that, you want to put a second piece of flex up to the top of the chimney. What my competition tells you to do, and shame on me, I had no other solution. When contractors would call and say, what do you do? I'd say, well, zip tie it at the top. After having seen the best practices way to do it, I realized that that was a very bad thing to tell them, because the zip tie is actually ovalizing both the exhaust pipe and the combustion air intake, choking off the appliance below. So you want to use combustion air. I'm going to show you what to do that with. Flex couplers, my competition has flex couplers, but if you're going to buy one of their flex couplers, you might as well buy another coil of flex, because that's how much their flex couplers cost. You buy one of ours, if you can save 5 to 10 feet, you have now had a coupler that can pay for itself. We have a female coupler, so if you are putting it through the drywall like my competition says you can, you have now a way to support it at the top. We're not leaving you at your own druthers, and I will show you all that. We're getting close to the end, so I need to zip through this. And then we have the best locking device on the market. No tools, opens up quick and easy. You saw how I did that, right? Remember junior high school? Remember Mary Jane? Remember how easily that opened for her? That's how easy it goes. And then it snaps right on. So, locking clamp snaps on, push the pipe in, bottom it out, pull it back out. That now allows for expansion and contraction, okay? So you're never going to end up with a system that expands and now it starts to buckle and bow because there was no place for it to go. Pull it out at 10 millimeters, and it's not like you have to measure anything. You're just pulling it up until the little inside pocket locks onto the female end, and now you're good to go. So now to take you through some of this so you can see it. So here's the combustion air. Flex will end up here. Foam rubber, this seals off. And then this really nice looking chimney cap goes over the top of it. These things go together super quick. So this goes on, combustion air comes underneath, and now you've got your own little chamber there. Look at that, I'm pointing at the other screen. You have your own little chamber here for combustion air, the combustion air coming in underneath here. And then going back to the speed side of things, when you want to put that flex together and put it in there and support it from the top, if you don't lose your O-ring, you go down 3 snaps. You install your gasket, you snap that in place, and this sits on the seat on the top of the chimney, and you've now installed your chimney cap. I I did do it in my brother's house. We did do it with the combustion air intake, and it did take us less than 15 minutes on the roof. If you're doing that with anything else, let me know. Our B-vent cap, I think I probably blasted right through there. So here's the coupler. And I was showing Steve our new Christmas gift to our wholesalers. This is going to be our sample kit box, so they can take it out and show you all the great stuff we have. And if you see it on the counter, you'll see in here, it's going to show you all the different types of installations that you might want to have and the components that you would need for those. And then a nice little picture of the components underneath. And then just to show off the locking clamp again, because I love it so much, look at this. Comes off just like that. No more prying any little clamps or anything else away. You can put it on afterwards, but for the purposes of presentation, you see that little space there? That's 10 millimeters. That allows for the expansion and contraction. All right. This device is that locking coupler, and it goes onto the coupler, snaps in, snaps on one end of the flex, onto the other end of the flex. You've got that put on in less than a minute, and now you've saved all that flex. When I was with the other guys, I would go from contractor to contractor. One guy started walking me out to a woodshed. I'm like, where the hell are we going? Because I got to show you something. I'm like, my uncle had a woodshed like that. I don't want to go back there. So we go back there, and he shows me this whole shed full of flex drops that he could never use again because the competition is selling those couplers at such a high price.
Well, I got to be honest with you. Looking at your couplings and the way you just snap everything together so quick, have you ever tried to? Your competitor where you used to work, I know where you used to work. It's not that easy to get it off. I'm being honest with you. It's not that easy to get it off and get a fitting detached. You just snap those things from fitting.
You gotta pry a little tab out of the way. You turn that whole connector ring into an S shape.
Got 3 guys pulling on it. Yeah, you know what I'm talking about.
Then if you use their coupler screws together. So instead of having, mine is going to have 5 parts, theirs has like about 6 or 7 pieces that are all going together that then need to be screwed and need to be torqued. And it's always a question, did you tighten it tight enough? It's just not a good device.
Snapped everything together in front of me. You were like, that would make my life easier.
And then one of our other cool devices that we do for best practices, this goes up into your attic space. This goes across the rafters. And now when you go through that drywall chase, you just clamp your flex to the side so that no nails can get to it. And then you go with the rigid wall up through the roof. What does our competition give you? They give you figure out a way to support the flex at the top. They give you this, but they don't give you anything like this. B-vent. So with our B-vent cap, comes in 3 pieces. You've got the base piece. We give you the hose clamp so that you're not going up there with sheetrock screws. Hose clamp goes on to one of these sets of fingers. So it'll go all the way down to a 3-inch diameter. You then zip the hose clamp on, a couple of tightens with a screwdriver. That's locked into place. This piece, and again, what's really great about our stuff is while it locks in with a little twist, you can take it apart. And now a chimney cap becomes a B-vent cap.
Jim, you've done this before. You've done this before, man.
I've done this before.
You're pulling them out like you're coming from every direction. I love it.
The little tabs on the side, I don't know if you can see them here very well, but those little tabs lock into this seat on your base, and that locks your flex now into the B-vent. Cap then presses over the top, exhaust goes out, and now you can bring combustion air in through that base. What's great about a B-vent, it was only used for gas. So there might be some aluminum oxide on the B-vent, but most jurisdictions let you bring in combustion air around that in order to get there. Okay, lock and clamp, I showed you that a couple times. May need an adapter, so we have adapters that fit into sockets that have gaskets in them, and we have those that have gaskets for other manufacturers. Luckily with NTI, they're using those 3-in-1s. So for 2 and 3 inch, no adapter is required. For 4 and 6 inch, we have a very inexpensive adapter that fits right into there. We've got a twin pipe termination. So it's going to come with the wall plates. It's going to come with the terminations. If you need the elbows for outside or the extensions, those are sold separately, but you can see how nice and clean a look that's going to give you from the outside. The black coloring just makes it look like a shadow on the wall. One of the other things I want to point out, again, my competition doesn't give you anything like this. So this is going to mount onto the wall joists inside of the house. So when you buy our horizontal termination kits, you'll have the concentric termination, the twin pipe to concentric, but you're going to get this piece with it. This piece goes, it attaches to the wall joist, and then you put the little screws that we give you with it into the sides, and now that's going to lock that termination in. Somebody hits that termination from the outside with a basketball, baseball, football, body slams it, and this is going to keep that locked into place. My competition is going to say, well, did you have the supports there? Yeah, but the pipe is designed to slide in those supports. And so this gets banged from the outside. It's going to dislodge everything that's on the inside. And this is going to prevent that from happening. Again, we're trying to give you best practices. We have the same thing for vertical terminations. They all give you, and we give you this as well, this little bracket that goes into the rafters in the attic to hold that in place. Allows you to do your pitched roof, allows you to do your flat roof. Pitch roof flashing, we've got 0 to 25, 25 to 45, and then the flat roof flashing. Here is the flex, chimney cap, flex, coupler, and then this is that neat base support that you were talking about on the bottom. It's pretty neat. But if the clean out isn't big enough, then I have to give you the same response as my competitor does. Well, take some 2x4 rebar and try and support it. Yeah,
Jim,
but
that's pretty good. That's a pretty good base. That's a nice.
It is a
base.
pretty good base. It's great for B-vent where you're going across joists, but if you can close off your chimney with something like this, now you're never going to have any downdrafting coming in, all that cold air, right? So if you're just using it for the flex, and now you have this at the bottom, well, you've got the pipe that's going in, and what do? Either they mortar that pipe in place, which is really bad because the mortar is going to scratch the hell out of the pipe and it's going to draw the moisture out of the pipe. Two bad things, right? So if you use this, right, you overcome that. You now seal off the bottom, no cold draft coming down. It's a bit more expensive, so when we sell our kits, we do sell them with this base support. But if you buy the individual components, it's going to cost you the same amount of money. In fact, probably less because we're not kitting it for free. So you're paying for the labor of somebody kitting something up where you can buy the individual components and save that money and buy the best in class type of installation. This is great when you're going across the joist and you put a hole in, you put this into the wooden joist. You put a piece of 2x4 on the other joist underneath here to make a shelf, and you're great underneath the B-vent with that. And this is what it looks like when you put that B-vent cap on there. And now you don't even want to take off the B-vent that's on the roof because it's already set for the snow height that it needed to be set for. So now you're just putting this up on the top, exhaust out to the top, combustion air in. Combustion air comes down through this leg, exhaust goes up through this leg. Easy peasy. And then there's that base support that we were talking about. Never want to do this Chimney sweeps do this with the older cast iron boilers. They're atmospheric. There's no condensate. This flex is made to be that. It's made to be flexible. So now think, this is here at room temperature, what I can do with it. Think about when this thing gets up to 130 degrees and you try to turn this outside. It's going to do this, and you're going to end up with a P-trap at the bottom of your chimney. 45-degree bend is the most you want to do with your flex pipe. This is the chimney kit. And then, so the things to know about flex: must be installed in the chase, could be drywall, can be B-vent, can be masonry chimney. In the masonry chimney or in the B-vent, you need to install these really neat spacers every 2 meters. Spacers go on, go around. This little Ziploc zips right in. And now these are flexible. I get asked this question a lot. These will flex out of the way, so it doesn't matter how tight the B-vent is. They will flex all the way up on themselves if they need to. The critical thing is that they're going to keep this from rubbing against anything abrasive, and they're going to keep it centered in there so that, again, it can't do something like this inside of the chimney. Was there a question there? I was hoping there was, because I need a drink. All right.
Like him.
The flex connectors, you saw how easily they go together. With a base support on and a support on the top, it can go 98 feet without any additional supports. You go beyond that, you want to take some type of a support. Even one of these spacers that I used, put a couple of holes in there, and then wire it up and anchor it up on the roof to support any extra weight you have. Multiple liners can be used in a single chase. So if you're changing out a apartment building that had a large boiler to maybe condos where they want everybody to have their own individual appliances, you can now run multiple flex up that huge stack that they had for their large boiler, and every appliance can have its own vent system.
Nice.
Okay, so we went through all of these different types of terminations that we have to offer. That leaves us with the simple venting criteria. You want to have a good straight line pitch. You want to have the proper location and a sufficient number of condensate drains. Most of the manufacturers handle the condensates through the appliance, but if you find that you're getting too many condensates in there, you'll want to put a condensate drain in. Maintain proper clearance to combustibles. We are zero clearance to combustibles, even in enclosed spaces. You'll find that if a water heater is going into a closet, they no longer even allow you to use PVC for that anymore, because PVC on a water heater relies on bringing in room air temperature into the exhaust to cool it down. If you are in a closet, the water heater is heating up that closet space. You no longer have a cooling medium for that flue gas, and you're going to melt your PVC. You want to minimize the number of elbows and T's, and it's always a good idea to try to maintain some accessibility for maintenance and inspections. You want to have a minimum of 1/4 of an inch slope. Polypropylene typically requires a 3-degree slope, which is why we provide you with 87-degree elbows and not 90s. And then you've all seen this chart where it says, okay, be a certain distance away from windows, window openings, doorways, forced air inlets, and all of those clearances are dependent upon the power range of the appliance that you're using. Okay, and then we have common venting. So NTI is coming out with their new cascaded systems. So the things, our cascade system, first there's a starter kit that says, okay, you're going to have at least 2 appliances, so you need 2 Ys. It's going to come with this end cap that has a condensate drain, and then a siphon and a hose for the condensates to go to the drain. You want to keep this branch parallel with the ground. You want to create a trough at the bottom of the vent system so all of the condensates flow back to this drain. Otherwise, if you have them pointing down, all of the condensates for however many boilers or water heaters you have in that bank are all going to drain to the first appliance. I've had appliance manufacturers try and tell me they've never had that problem. So I was in the tech center on the West Coast. They said, oh, no, we don't have that problem. Then I went to the tech center in New Jersey and they said, we're throwing the flag. That's BS. That first appliance always has it. And that's probably why. And it is why, because they used to just show PVC tees because they were the king of PVCs when they came out with their tankless water heater. And then we have extensions for all those. And we have them in multiple diameters and for everything that you might need. Do's and don'ts, feel free to contact me for sizing, bills of materials, proper venting techniques. Any question you have about venting is going to make it a safer system. And I'm happy to either answer or find the answer for you. Even if it's somebody else's system. I might be, a little bit more coarse about it if it's somebody else's system, but I'll give you the correct answer anyway. Always make sure you use spacers in a chimney or B-vent chase. Don't use those spacers inside the drywall. It'll sound like rodents scratching on the wall every time the appliance turns on. Just use some supports that'll keep the flex away from the wall so they can't stick a nail or a screw through it. Always use the Echo manufacturing supplies screwed for concentric. We don't need you finding stainless steel screws that are 1.5 inches long and screwing right through our vent system. You'll end up with recirc and your system will just rumble and never really run right. Always install flex within a chase. Support the single wall every 3 feet on the horizontal and every 6 feet on the vertical. Things that you don't want to do. Don't use too much lubricant, okay? It's just a sloppy mess. Just make it shiny on the end so that it slips past the gasket and go on with life. Don't put screws in single wall or flexible piping. You smirk and laugh, but I had somebody wanted me to fly all the way to Minnesota so he could show me that every one of my connections leaked. And I said, wow, we didn't put gaskets in any of our pipes. And I went there just to find out that he had put screws at every connection because that's what he always did with B-vent. This is not your B-vent type of appliance anymore, okay? Don't make greater than a 45-degree turn with flex. It'll start to droop. It'll build up with condensates. It'll become a P-chop. It'll block your exhaust. Never leave the flex exposed. Don't install flex at temperatures below 40 degrees. It will be brittle. You could crack the 2-inch. You will not be able to move the 4-inch, and the 3-inch will just be very difficult. Keep it warm in the van, bring it down in the basement. A 40-foot roll is going to weigh, I'm going to say 15 pounds max. If you can't slide that up the chase, then you probably should be finding a new occupation. It's just that easy to install from below. And then never run flexible liners in a horizontal. They're going to droop. They're going to fill up with condensates. They're going to block your exhaust.
Thanks for watching the video today. If you'd like to check out more videos, see the link below. Don't forget to like, share, and subscribe to our channel for all the future updates. And also check us out on Facebook, LinkedIn, and Instagram.